We're going to be starting Unit 5. In Unit 5, we're going to be looking at stuff with possibilities and probabilities. Today, we're going to start with the counting principle, and the learning target is that you can solve problems involving both independent and dependent events. We'll talk about what those are. This first problem on your note sheet says the number of possible license plates for a state is too great to count by listing all the possibilities. It is much more efficient to count the number of possibilities by using something called the fundamental counting principle. So what we want to do for this problem is try to figure out what would be the total number of different license plates that you could have. And we'll come back to this problem in a little bit here after we talk about the fundamental counting principle. All right, some things that we need to be familiar with here. These terms are all going to pop up throughout the chapter. One of them is an outcome. And what we say is that an outcome is the result of a single trial. So one example would be flipping a coin. If you were to flip a coin, you have two outcomes, heads or tails. So you could have one of either. So there would be two possible outcomes. Another term we're going to be talking about, sample space. Sample space is the set of all possible outcomes. So if you were to roll a die, the sample space would be 6 because you have all the possible outcomes of getting like a 1. If we were to spin our dice here, we could get 1, 2, 3, 4. There's lots of different outcomes that can come from spinning a dice. All right, another term, event. Event consists of one or more outcomes of a trial. Okay, so example would be if you were to roll a die. Okay, die means single dice. Another example would be flipping a coin. The actual event would be what you're doing. Couple more terms that we need to know here. Independent and dependent events. An independent event is outcome of one event that doesn't affect the outcome of another event. So when your choices are different, or when your choices don't depend on each other, then it's independent. Okay. So this would be like our license plate problem we're going to be coming back to. Your choices for different letters or numbers are not dependent on the other one. As you can see in this license plate, U is used twice, so you can use repeated things. That's independent. All right. So the other type of event you can have then is dependent events. This is where the outcome of one event does affect the outcome of another event. So choosing a piece of candy from a jar without replacing it, and then choosing another piece of candy, this would be dependent because that first choice affects your chances of getting a different choice. So when one thing affects the other, that's dependent. All right, so we talked about these terms. We're going to try a couple problems here. We'll come back to that license plate problem here in a second. When you read through this first one, they want you to find a chicken, or that a sandwich cart offers customers the choice of a hamburger, chicken, or fish on either a plain sesame seed bun. How many different combinations of meat and a bun are possible? So one method you can do to do these types of problems is make a little diagram called a tree diagram. And how you do this is list out your different things. So we have hamburger is one possibility, chicken's another possibility, fish is another possibility. And then each sandwich you could have either a plain or sesame seed bun. So if we do plain or sesame for each one, we can see now, counting up, that there is 1, 2, 3, 4, 5, 6 total possibilities. Okay, so you can use this little tree method as a way of doing it. But a quicker way is using what's called the fundamental counting principle. And what this says is if one event can occur m ways and another event can occur in n ways, then the number that both events can occur is m times n ways. This can be extended to 3 or more events as well. For example, if 4 events can occur, then the number of ways all 4 can occur is multiplying all the ways together. So for this one, if we take our choice of meats, which is 3, and our choices of bun, which are 2, and multiply those together, you get the same answer of 6 possible sandwiches. So using fundamental counting principle is often a much faster way of doing this. Okay. Also, we want to be able to answer is choosing meat and a bun here independent or dependent event. If you choose a certain one like chicken, do you have to choose a certain kind of bun? No, these are totally separate things. Choosing your meat and choosing your bun don't have anything to do with each other. We would say this is a independent event. The choices of each are separate from one another. Okay, so now that we've tried one, let's go back to that license plate problem we started with. Let's see if we can find the total number of license plate possibilities. So if a license plate has 3 letters followed by 3 numbers, how many possibilities do we have? Well, if we think about our choices for letters here, there is 26 total possible letters for the first one, 26 possible for the second one, and 26 possible for the third one, because this would be independent. Each choice for letters isn't affected by the one before it. So now we got to think numbers. How many possible numbers are there? Well, 0 through 9 are different numbers here. And that would be 9 numbers, and if we include 0, that's 10 possibilities. So we have 10 possibilities for the first one, 10 possibilities for the second one, and 10 for the third one, because there's no repeats. Or you can have repeats when you make a license plate. So if we multiply 26 times 26 times 26 times 10 times 10 times 10, should give us our total number. Another way we could write this, since we have repeated multiplication with some of these, is to do 26 multiplied 3 times would be the same as 26 to the third power times, we got 10 times 10 times 10, that'd be 10 to the third power. So that'd be another way of entering it in your calculator too. Let's multiply this out and see what we get. I'm going to use the exponents here. So 26 to the power of 3 times 10 to the third power as well equals this many possibilities. Quite a big number here. You get 17,576,000 different license plates. That's way more than the number of people in Minnesota. So we're not going to be running out of license plate combinations anytime soon. All right, let's look at a few more of these. Number 2, it says to check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event. Then determine how many possible codes. So in this problem, did they say that you can't use a number more than once? No, you can use a number repeated times. So the choice for the second is not affected by the first. This would be independent. So we just talked about if it's any number, we got 10 choices. For the first one, there'd be 10 choices for the second one, there'd be 10 choices for the third one. So the answer here is going to be 10 times 10 times 10, or 10 to the third power, which equals 1,000 possible codes here. So there'd be 1,000 possible. Okay, let's try another one. Number 3, Carly wants to take 6 different classes next year. Assuming that each class is offered each period, how many different schedules could she have? Okay, so we got to think, is this independent or dependent? Could she take the, let's say, biology, all 6 classes? No, she needs to take different classes. This is dependent. Her choice for her first period is affecting her other ones because she's not going to take the classes more than once. So this is an example of dependent. So now we got to think, how many choices does she have for her first hour? Well, if she's taking 6 classes, she has 6 possibilities. Okay, now second hour. Okay, let's say she took biology her first hour. Now she has 5 classes left to choose from. So now she has 5 choices. Let's say she takes algebra. Okay, now she's down to 4 classes left, so she's got 4 choices next, then 3, then 2. Finally, for her 6th hour, she's got 1 choice left. So the answer would be 6 times 5 times 4 times 3 times 2 times 1. Now, we could go through and do that and type all that in on our calculator. Luckily, in math, there is a button that can do this type of multiplication for us. So when you multiply each number times the next number down all the way down to 1. And it's called the factorial button. And it looks like an exclamation point. Okay, so if we type in 6 factorial, what your calculator will do is type in 6 times 5 times 4 times 3 times 2 times 1 for you and figure out what that equals. Okay, on your calculator, you can find that button under the math menu. So let's hit our 6 because we want to do 6 factorial. Hit math, and then if we scroll over to the second menu option of number on top, and keep going over to, there's this one that says complex, and then over to the one that says probability. This probability menu has the exclamation point or factorial button as number 4 there. So if you hit that and then hit enter, it'll do 6 times 5 times 4 times 3 times 2 times 1 for you. Looks like if you multiply all that together, there's going to be 720 possible schedules that Carly could take. Okay, so factorial button figures out for you that multiplication. Okay, you should be able to find it on any TI calculator under the probability menu. If you have a TI Nspire, it's on your right-hand side down by the keypad. Okay, number 4. If a garage door opener has 10-digit keypad and the code to open the door is a 4-digit code, how many codes are possible? Why don't you pause it and try this one quick and answer, is it independent or dependent? All right, let's see how you did. This should be an independent event. You can use numbers more than once, so it's independent. Okay, there's 10 possible numbers for each one, 10 times 10 times 10 times 10, which is the same as 10 to the 4th power. You should have got 10,000 possible codes was the answer. All right, last one on your note sheet. Again, why don't you pause it and try this one out and answer, is it independent or dependent? All right, let's see what you did. It says each player in a board game uses one of 6 different pieces. If 4 players play the game, how many different ways could the players choose their game pieces? This would be dependent. Okay, if player 1 chose the car here, that means player 2 can't also choose the car as their game piece. So it's dependent on what the person does before. So if there are 6 different players playing the game, we got 6 choices for player 1, 5 choices for player 2, on down. Now be careful here. If you did this and did the 6 factorial again, that's incorrect. And the reason that that's going to be incorrect on this one is that there's only 4 players playing the game. So we got 1 player, 2 player, 3 player, 4 players. We need to stop here at 3 and not do it all the way down. So this one we are going to have to type in and figure out what this is going to equal. 6 times 5 times 4 times 3. That's going to be our answer on this one. So 6 times 5 times 4 times 3 gives us 360 possibility. All right, try the practice sheet, see how you do.